Welcome to my new calculus channel. My name is John Gabriel, and in today's video, I'm going to be discussing what is a differential in calculus, okay? A differential, and what it means exactly, and also I'll tell you a little bit more about what that elongated S means in mainstream calculus. And so hopefully after this video, you'll have a better understanding. So let's begin. Okay, so now, a long time ago, I actually began to study calculus when I was about 14, by the way. And one of the books I came across was the one by Hilary Sheward and Neal. And it's mentioned in this paper by David Toll, who's a mathematics education researcher from the University of Warwick. And it's called Conceptual Foundations of the Calculus and the Computer. Actually, his article is not really interesting. And the only reason I pulled it up is because, I shouldn't use the phrase is because it's wrong, is that it contains the passage in Sheward's book, okay, which caught my attention when I had first read it. I don't have a book now. It's a piece of junk, and I wouldn't buy it if I were you. It was written by Sheward and Neal. And so they wrote in their book, before I start to read this to you, let me first tell you a little bit about Sheward. She was actually the president of the Mathematical American, or the MAA, Mathematical American Association, or Mathematical Association of Mathematics. I don't really care what it stands for. It's not a very worthwhile organization anyway, in my opinion. Now, she was the president for approximately a year, and Sheward was an educator in the UK. So she and Neal got together and they wrote a book on calculus called Teaching the Calculus. So here's what they wrote about differentials. So the student has to learn that in spite of all the evidence to the contrary, actually, there is no evidence to the contrary, by the way, which seems to him to build up from statements such as the one that you see here, dy dx multiplied by dx dt is equal to dy dt. Dy dx is not a symbol for a fraction, but for the limit of the gradient of a chord. That is false, okay? Dy dx is exactly a fraction. It's a fraction of symbolic differentials, okay? Dy and dx are differentials. And it can be written in many ways because you can have equivalent fractions, right? So what it really means, and I've explained this in a previous video, the one which I talk about Gilbert Strang. And so let me go there. I just want to move this out of the way. This one here, let's just see. Yeah, it's called Academic Ignorance and Stupidity, special on Gilbert Strang. I've actually mentioned a lot of things with respect to an instantaneous rate, which is nonsense, and also the way Strang approaches the calculus, which I'll give you an example from his book in a moment. But I first want to complete my comments on this. So now, this paragraph here doesn't seem that bad until, of course, you get to the second one, which is the following. It says, a school textbook advised students, okay, and this is the paragraph. Dy dx must at least for some considerable time be regarded as an inseparable whole, ... It does not in any way, any simple or straightforward way, mean anything like dy divided by dx. Actually, it does. But anyway, and a statement such as dy dx times dx dt is equal to dy dt by canceling dx is just so much gibberish. Well, and this comes from SMP Advanced Mathematics, page 221. Now, this is gibberish, by the way. Actually, dy dx and this expression here, this Leibnizian expression here, is exactly correct, and you don't have to consider this as anything but what it is, a fraction. That's a fraction, and this is a fraction, and this is a fraction, and you can cancel out dx exactly as the student thinks, okay? So it's not at all gibberish. Now, what does it mean? What does it all mean? Well, look, as I explained in this little applet, which I used in the Strang video, dy dx is just simply the gradient of the tangent line to a given point, okay? So that's all dy dx is. And of course, you can have different dy dx's. See? That's all that means, right? Okay? Nothing is changing. Nothing is changing. See this value here, the tangent gradient? It's approximately 170.52, and nothing is ever changing, okay? And all these tangent lines have been here in past perpetuity, and they'll be here in future perpetuity. The tangents don't change, nor do their gradients. And fast and slow have no applicability here, right? It's just nonsense. So you can go watch the Strang video and see what he says about that. Now, Strang is that moron professor from MIT, okay, who's written many books and was also, incidentally, on the Abel Prize Committee at one stage. Okay, so now, that's all that dy dx means. It's just, for crying out loud, it's just the slope of a tangent line, and it's exactly a fraction. See here, dy dx is exactly 961.23 over 6.35. It doesn't change, see? These are equivalent fractions, okay? And of course, the mainstream calculus is buggered, because if you try to do this, let's see if I can get it there. If you try to do this, you'll end up with 0 over zeros, okay, which is total bullshit, right? Okay, let's just cancel that. So 0 over 0 doesn't give you the gradient, which is 151 in this case, or whatever it's supposed to be. Let's just move that away. Yeah, it's 151, okay? So the new calculus, by the way, is geometric, is based on sound geometry. So you don't get nonsense like you do in the mainstream calculus, which is a bogus and a flawed formulation. And of course, you can download the most important mathematics book ever written for free. You don't have to pay for it. But guess what? If you download Neil Sheward's book, it costs approximately $51, and it's a piece of crap. It's really worthless junk. In any case, this David Toll continues here to talk about students are told that the dx in integral of fx with respect to dx means certain things, and they have to think of these as separate symbols. But really, yes, you can make the substitution, and the reason you can make these kind of substitutions is that this here is exactly, pay attention, exactly the product of two arithmetic means, okay? So that's why you can do these substitutions, and it's perfectly legal, right? And these here are fractions, and du and dx are differentials. What is a differential? It's just a finite difference. If you go back to that applet, this here is just the difference in the y's, okay? That's all it is. In this y coordinate and this y coordinate, it's just the difference, nothing else. There's nothing special about it. So if you can calculate rise over run, You know what a derivative is, you know what a differential is, and you know what is a derivative. Okay, and so dy dx is exactly a fraction, and dy and dx are differentials. Now, what does Strang have to, how does Strang start his book? Well, Strang says, let's read a bit about what he says. He says, the right way to begin a calculus book is with calculus. Well, that, I don't even know if that's a necessary statement. It's totally redundant. By the way, I have a lot of hatred for Strang. He has caused me considerable harm in many respects. For example, cannot get a teaching job because of the lies he spread about me. He and Dan Christensen, who happen to be very good friends on Math. But in any case, I don't care about that because the truth to me is more important. And eventually, this man will be remembered in infamy. This chapter will jump directly into two problems that the subject was invented to solve. Well, he begins with the concept of speed. But what Strang doesn't realize, because he is such an orangutan moron, is that in order to use calculus, you need to have a function. You can't just write f here is equal to the distance, okay? You can't do that because you need a function. To be brutally direct, if you do not have a smooth function, which means it must also be continuous, by the way. What does smooth mean? Smooth means you can only have one tangent at every given point, okay, in a certain interval. So, for example, you'll see this sort of crap eventually, where you have trapeziums. Well, let me draw it for you to show you. So you've probably grown up in calculus with exam questions that look something like this. Okay, stuff like that. This here is not even a function. It's composed of several functions. Up to there, that's one function. That's another one. That's another one. That's another one. So this here is not f. It's composed of many different functions. There is no such thing, by the way, as a piecewise function. It's garbage, okay? It's an ill-formed concept. A function consists only of one rule. Okay, now in any case, what Strang doesn't realize is that if you have a speedometer, it doesn't correspond to any particular function. For example, if you're driving on the road, it can look like something like that. You know, oh, see? Now, how do you integrate this function? And how do you, for crying out loud, find the distance, and the distance, not only the distance, but the speed and the acceleration and anything else from this particular function? Now, does it make sense to talk about this here? This is random. It may be like this one time, and the next time it may be completely different, okay? It may be something like this. It may be, let me get this out of the way here. It may be something like this. Now, why can't I draw there? One moment, please. I want to choose red. Okay, now, so the next time it might be something, hello, something like that, right? Which is totally different. So Strang's an idiot, okay? Just like most of your math professors are idiots, and your math teachers are also idiots because they've never understood calculus. And Newton and Leibniz also were experimenting. They did not know calculus or understand it in the way that I do, okay? And I was the first to create a rigorous formulation. Okay, so Strang starts off with this garbage idea of speedometers and distance and velocity. That's not what calculus was invented to solve, by the way. And this is not how Newton started. So it's very deceptive. The way Newton started is exactly like this. He was trying to find the slope of a tangent line to a curve. See, like this, all right? That's what he was trying to do. And the way Newton did it is, well, he didn't really do it. He failed miserably, but this is how he began to experiment. Okay. So he basically began using a chord. So he said, well, if this is a tangent line, let me start with, oops, that's supposed to be a straight line, by the way, different chords like that. And then he started bringing the chord closer and closer until it resembled the slope of this red tangent line. Okay, so in other words, like that, and then like that, and then like that, and so on. And of course, this idea here was basically groping around in the dark. And Leibniz did exactly the same thing, okay? And it's completely wrong. Well, of course, if you look at the rigorous new calculus, it doesn't do that, okay? It uses a parallel secant line to a tangent, to a given tangent line, okay? And there are many parallel secant lines. And the fact that there are many was proved over 2,300 years ago by my ancestors. Well, some of my ancestors. I'm only 55% Greek. And they proved that there are many parallel lines which are parallel to this tangent line. So at any rate, that's how Newton and Leibniz were groping in the dark, and that's how the idiots who have taught you your bogus mainstream calculus understand their calculus. So they've never understood exactly why calculus works and what the different symbols that they use actually mean. Okay, so I would advise you to watch these videos slowly and study them. And of course, please download my free ebook, because my free ebook is the most important mathematics book ever written. Okay, and you will see in my free ebook that you can derive calculus systematically from geometry, and everything else, by the way, systematically from geometry, which is also systematically derived from nothing, because perfect concepts are derived from nothing. And here's this last thing I want to show you now. So I used to teach A-level mathematics, and when I worked in China, I worked for a certain company called DuPont for a short while. And while I was there, I compiled several model solutions to the A-level papers. And here's one of them I compiled. And the type of questions you might find are some like this. For example, here, the variables x and y are such that y is equal to -1 when x is equal to 1, and you're given this equation here, which is a differential equation. Now notice dy dx is a fraction, okay, and it's treated as a fraction. And in order to solve this problem here, you have to treat dy dx exactly as you would a fraction, okay, and that's what happens here. So you basically, in this example here, just to find what dy dx cubed is, you treat it as a whole variable, okay, and you find out that it's 27, and therefore dy dx must be 3, which is the cube root of 27. By the way, if this should only be treated as, considered as a whole and not treated as dy dx, you can't do this sort of thing, okay? Do you realize that? You can't take the cube root of something that is not a number. It makes me angry when stupid people in the mainstream, my intellectual inferiors, say stupid things and confuse students, all right? So this is the way you find the solution to a problem like this, by treating dy and dx as differentials. And in your bogus mainstream calculus, you don't have an exact definition, but there is an exact definition in the new calculus. Differentials are well-defined, and derivatives are well-defined, and integrals are also well-defined. There is no use of the concept of infinity or infinitesimals or any of the other nonsense that you will find in the mainstream. Well, I hope you have enjoyed this little presentation, and that you will have learned much more than you learned at school and university about the meaning of calculus, and that you'll join me again at some future time to learn more Well, this is the new calculus, and I'm John Gabriel. Goodbye.